In this class, we are going to discuss about the derivation of utility maximization using the constraint optimization method. The Lagrange functions can be used in the optimization of utility of the consumer who faces a constraint. We know that the constraint faced by the consumer is his budget, and the consumer is in equilibrium when he maximizes his utility given his income and market prices or the budget line. The consumer's equilibrium conditions are, we know that there are two conditions for a consumer to be in equilibrium or for the maximization of the consumer satisfaction. The first one is the marginal rate of substitution must be equal to the price ratio. That is, marginal rate of substitution equal to marginal utility of X divided by marginal utility of Y, and that must be equal to the price ratios, that is price of X divided by the price of Y. The first condition is that the marginal rate of substitution must be equal to the price ratio, that is MRS equal to MUX by MUY, that equal to PX by PY. This is a necessary condition. Or at the point where the slope of indifference curve must be equal to the slope of budget line. This is marginal utility of X by marginal utility of Y is the marginal rate of substitution of X over Y. It is the slope of indifference curve. Px by Py is the slope of budget line. Therefore, the consumer is in equilibrium when the slope of indifference curve is equal to the slope of budget line. And the second condition is that at the point of tangency, the indifference curve must be convex. This is the second condition for the equilibrium. That is, at the point of tangency, the indifference curve must be convex. And this can be explained as follows. Given the indifference map and the budget line, the equilibrium is defined at the point of tangency of the budget line with the highest possible indifference curve. It is given in the following figure. That is, the equilibrium of the consumer is obtained when the slope of budget line, the budget line is AB, is equal to the slope of the indifference curve. Here, the consumer is in equilibrium at IC3. Here at point C, the marginal rate of substitution, that is marginal utility of X divided by marginal utility of Y equal to the price ratio, that is Px by Py. Here, the slope of indifference curve is equal to the slope of budget line, and the consumer satisfaction is maximized. And the proof of that point is given here. An indifference curve is given as U equal to a function of xy, and the budget constraint is defined as M equal to price of X of X plus price of Y of Y. And step 1 is rewrite the constraint to equate to 0. It is the same way we can derive the utility condition, that is it is the same steps for the Lagrange multiplier solution is used here. The first one is rewrite the constraint to equate to 0, that is M minus Px of X minus Py of Y equal to 0, and then multiply the constraint by lambda, then we will get lambda into M minus P of X minus Py of Y, and formulate the Lagrange function. How we can formulate? By adding the objective function. This is the objective function U, a function of xy, plus this function, that is L equal to L is the new Lagrange function, L equal to U xy plus lambda M minus Px of X minus Py of Y. And next step is find the first order condition and the second order condition. That is, the first order condition means find the partial derivatives with respect to the three unknowns x, y and lambda. Dou L by dou X equal to dou U by dou X minus lambda Px. That is, differentiate this function with respect to X. This is given, the partial differential of this function is given as dou L by dou X is the first differential or the first variable with respect to the differential of X with respect to L, that can be written as dou U by dou X minus lambda Px. Here Px is the value of X is 1, therefore minus lambda Px. And dou L by dou Y likewise is dou U by dou Y minus lambda Py, and dou L by dou lambda equal to M minus Px of X minus Py of Y equal to 0. Divide the equation 1 by 2. by the equation 2, that equal to dou u by dou x divided by dou u by dou y, that equal to px by py. This lambda and lambda cancels out. Then what is this dou u by dou x? It is nothing but margin utility of x. What is this dou u by dou y? It is margin utility of y. That is margin utility of x divided by margin utility of y equal to px divided by py. Or the consumer is in equilibrium when margin utility of x divided by price of x equal to margin utility of y divided by price of y equal to margin utility of y divided this cross multiply margin utility of n divided by price of n. This is the first order condition. The second order condition requires that at the point of tangency, indifferent curve must be convex to the origin, and that is the determinant of Hessian bordered Hessian matrix must be greater than 0. That is, the second order condition requires that the bordered Hessian matrix, the second order condition requires that the determinant of the bordered Hessian matrix must be greater than 0. This is about the utility condition. This is about the utility maximization condition for the consumer using the Lagrange multiplier.